frameworks. An important note to for here is that the domain is the center of all the other layers, and it will not depend on anything else. This is very important for isolation and also for everything that we talked about so far. So what it mainly consists of in terms of our application is our business and application rules, which are going to be mainly stated as use cases in our application, and also repository, and finally some models to go along with it. So here, as previously stated, what we are going to test here, we are going to test the use cases because they are our actual business logic and what our application will actually accomplish, what our domain will do. So in the testing part, we'll cover testing of these use cases. And we'll actually need something to provide all of this, all of our use cases and all of our repository implementations. So naturally, we will need some dependency injection. And in our case, we will include all of these classes in our service locator library, which is going to be getIt. And now Evgeniy is going to show a little bit of how we've actually accomplished this.
Yep. Okay, good. So as we said in the beginning, we're separating our features. We are separating our packages vertically, which means that we have here this package features, which right now it has the movies feature. So let's start as we're talking about the domain, and what we should start with are the models. For this sample application, the models that we have, they're pretty straightforward. We have a simple movie class, which should behave like a, let's say, data class in Kotlin, or it's like a plain old Java object that contains no logic inside, and it has only fields. So we have the ID of the movie as well as some kind of an image that represents this movie. What we have done here is we have implemented as well the equals and hash code functions, which will be needed later on for comparing those movies. And I know that there are libraries in Flutter like Freest that can be used for this. But to be honest, some of those libraries, you're coupling your domain logic, which should be independent of stuff like this. And this is not good. That's why we decided that we are going to implement those on our own. Also, actually, these are automatically generated. If you just right-click, you can you can select generate equality, so it's going to work. It wasn't that difficult. Then we have another class here, a movie details, which is an extended version of a movie, and it has a lot of more fields that we're going to use later on as well. You can say that we have a duplication, like the ID and the image, but this is absolutely fine because duplication sometimes is not a bad thing, as we want to have the movie and the movie details classes like separate objects that might change for different reasons, and we don't want to couple those objects together. Then another important aspect is that we have domain errors. So we have a domain exception for movie popular exception, and it's popular. You're going to see why, because we have domain logic for fetching popular movies. And then we have a movie details error, which is again an exception that we care about in our domain logic. So that was about the models, and I want to show you now the actual use cases. Actually, you're going to actually we have only 2 use cases, but an important aspect here is you should, especially for use cases, repositories, you shouldn't work with concrete implementations. You should hide your, you should code against abstractions, as Boyan stated in the beginning. So let's say we have a use case for getting popular movies, and it's pretty simple actually. It's an abstract class, get popular movies, and you can instantly see what is the result type. It's a future of list of movie. Something interesting to note here is that we are the name of this function. The use cases, they should have only one function. The name of this function is call, and this is on purpose because later on we can actually invoke this call without stating it. You will see how. Then we have the implementation for this use case. The implementation is really, really straightforward. What we do, we are injecting the movies repository as a constructor parameter, and then actually we are just delegating the movies repository get popular movies, and that's it. Okay, someone might say, okay, but why do I even need use case if it's just invoking the movies repository? Well, you need to specify what is the user going to do. So he's going to actually, the use cases represent, as Boyan said, some user behavior. So there's going to be a user behavior for getting popular movies. Okay, then I need a use case for that. Okay, so the next thing, the other use case is getting the movie details, which is absolutely the same, with the single difference is that we are passing a movie ID as a parameter to the call function, and we are getting back a future of movie details. Then again, we have an implementation for that, and it's similar to the previous one. We have a movie repository as a constructed parameter, and we are invoking get movie details of the repository and return it as a result of this use case. Okay. And the last package that we have in this is movie repository. So the movie repository is just an abstract class, and this is really important. This is really important. As you can see, it doesn't have an implementation here, and it's going to later on have an implementation somewhere else. But having just an abstract class of a movie repository here is going to hide like the domain logic behind an interface, and actually does the domain knows where it gets the popular movies from? No. Does it know where it gets the movie details from? No. But it shouldn't care. It just cares that he's going to get this information somehow. And yeah, that's it. And I think this is for the domain. Why we started with the domain? Well, because this is what defines our application business rules, and this is how we should start writing a new feature and a new, like, when you have an already existing application, when you start writing a new feature, you should probably start with your domain logic.
Yeah, I just want to add something to this. You might have noticed already that first, while talking about the domain layer, we opened features and then movies as a feature, and then we switched to the domain layer. One thing that I very briefly mentioned in the introduction is that we're using package per feature kind of separation. And this is important because your features, in this manner, you will see that the feature has its data layer, DI, domain, and presentation layer. Each of the layers that we mentioned are contained in this feature. And there is another way of doing this, which is like you can have these layers and all of the features inside. But this further separates and isolates all features, and it's a little bit better. So I just wanted to know that. Okay, so we can continue with the next important layer.
Actually, I think we forgot to mention about the actual testing and the DI.
Yeah, okay. So should we mention now how you test the use cases and maybe how you provide the dependencies? Okay, let's go back then into the code, and we'll just show first of all, maybe how you provide the dependencies, and then how you test.
Actually, the opposite would be better. Sorry about this back and forward. Again, the test package here follows the same structure as we have in our lib package. So we have now the features, movies, domain, and I have a test for, I'm just going to show you one of the tests, as the other one is absolutely the same with just details. So let's say get popular movies use case implementation test. And something to note here is that we are using, for mocking our dependencies, we are using mocktail, a really nice library, and it eases the life a lot when you develop in Flutter. And what happens here? We have the get popular movies use case implementation, which is, this is a keyword, by the way, in testing. It means system under test. So you should probably mark it. If another developer sees that SUT, he'll instantly know that this is the thing that we test. So the thing that we test here is the get popular movies use case implementation, and you just pass on a mock version of the repository. And that is why, guys, it's really important that we provide our dependencies, our external dependencies to our system under test from the outside. Because now I can mock the behavior of this repository, and I can actually test my get popular movies use case implementation. So for the simplicity, and actually it's pretty simple testing a use case, it has only one test, and it's actually call, which is the function in the use case. Call should return a list of movie from the repository get popular movies. And exactly that's what it do. I'm mocking the behavior of the movies repository get popular movies, and I wanted to return a future value of actually of a list of movies. Sorry. Oh, yeah. Then what I do is I'm awaiting the result of my system under test of the use case. It's giving me back a list of movies. And what I'm expecting is that this list of movies is actually the same as the list of the object that was returned from the repository. And if you run the test, it passes, and actually this test is pretty straightforward. And the test for the other repository is again the same. How we implemented the tests, however, we have followed something called TDD, test-driven development. So the idea behind it is you write the tests before you have the implementation. That's the key part. And it helps a lot of not writing code that you don't use. And actually, it helps a lot of having really high coverage of your code. And the other thing that we wanted to show is the DI. So how we provide these use cases. So again, if we go to the movies, if you go to the DI, we have created a simple class, movies dependencies provider. Okay, and actually, as you can see, it doesn't depend on any external library. It just have a few functions providing some dependencies, and these are actually the functions providing the use cases. So the idea here is that the return type is the abstract class, and then the actual implementation of the function is the implementation of this use case. All the external dependencies, again, are passed as parameters. And actually, there's a thing that needs to happen. I don't want to show you now how we group this with getit, a library that Boyan mentioned we are going to use for service locator. We can do this in one place at the end. So that's it.
Yep. Let's continue on, as we spent quite a bit of time. Okay, so the next thing we're going to cover is the domain layer, but here we'll...
The data layer.
The data layer, excuse me. But we're going to do it a bit separately. And what we're firstly going to be looking at is the repository implementation. One important thing that Evgeniy mentioned in the domain layer is we only had the repository interface, or in our current case, the abstract class for the repository. And now the implementation will live in the data layer. So this is what the data layer is. It contains the implementation, and if you have one or multiple data sources, which we're not gonna do here, and the data layer is also responsible for coordinating and orchestrating all this data. So there's not a lot of things to look at here apart from the repository implementation. We're going to look at also how to test it, and maybe briefly also at the dependency injection for it. Yeah.
Okay. So the link is with the repository, as Boyan said. It's hiding where the domain is getting its information from. It's orchestrating the data flow, and it's hiding the complexity of systems like having a database, having a network, or something like this.
Or cache or anything.
Or cache, yeah, of course, or anything else. So now we have, in our data package, we have a network package and repository package. And this repository package is actually containing an implementation of the movies repository that was defined in our domain layer. This way we achieve dependency inversion. And what this movies repository looks like, again, all the external dependencies that are used in the repository implementation are provided through constructor injection. And these repositories are movies API, which is an API where we get our network calls in. Then we have two mappers, which we are going to explicitly talk about. And then we have implementations of the two functions, get popular movies and get movie details. The implementations are really straightforward. What happens here? We have the movie API, and we are invoking the get popular movies function from this movie API. Then this is a function provided, like a function for future. Then what we do, if we have a result which would be a type of movie DTOs, we go through this list of movie DTOs, and we are mapping those using the movie mapper, which we provided here, to a type of movie. So if you see the mapper here, you can see that this mapper is mapping movie DTO to movie, and this is really important part. We are going to explicitly talk about this. So now this get popular movies from the repository. It's giving back a list of movies, and which is different from what the API returns, which is a list of movie DTOs. DTO comes from data transfer object, if you're not sure about. In case of any error, however, we are mapping this error to a domain-specific error, and this would be the movie popular exception that we have seen in the models. And absolutely the same thing happens with get movie details, apart of having here a parameter movie ID. We get the movie IDs from the API. We map the movie details DTO using the movie details mapper. And in case of any error, we return movie details exception, which is a domain-specific error. And now I'm going to show you the test for this. It's in the data package, and it follows the same structure. So now, as the movies repository implementation, it has 3 external dependencies. I need to create 3 mock versions of those dependencies, which is absolutely okay. It's not that difficult. I have 3 versions of those. I pass them, and now I can play with them. The first function that I have is get popular movies should return a list of movie when API is successful. So as you can see, you should name your tests in a way that it explains what it does. And of course, it can have keywords like should, when, so it's pretty visible what should happen and when it should happen. And here I'm mocking the behavior of the movies API, that when I invoke the get popular movies, then I'm returning a future value of movie DTOs. And when the mapper is invoked with the certain movie DTO, I'm giving back a movie. Then I'm doing the actual action, and I'm expecting that the result of this action is the same as the one that I was expecting. Of course, you should as well test your behavior when you have an exception. So get popular movies should throw movie popular exception when the API fails. And this is also pretty easy. I'm just mocking the behavior of the movie API to throw an exception. And here I'm just expecting that when I evoke get popular movies, I will have an exception. And that's it. But this exception, however, is, as you can notice now, is the domain exception. I won't explain the other test because it's absolutely the same. It follows the same structure. Regarding the DI, and sorry, the DI, it's sorry, yeah, it's similar to what we have with the use cases. So it's just a movies repository. It's just a function in the movies container. Provide movie repository. It's giving back movie repository the abstract class. It returns the re-implementation, and all the dependencies are provided through the function parameters. So that's it.
Okay. So the second part that we're gonna look at our data layer is actually the network part of it. So here there is one important thing to look at. We'll look at how the API is implemented, what the mappers actually do, and some models. But important thing to note here is about the models. Something that we're using here is a new object, and the intent of this new object is to encapsulate the absence of an object and providing a substitute alternative for that. This sounds a little bit technical, but it's actually very, very simple. And now we're going to show in code what exactly is this and why it is important to use this pattern in your models.
Also, no object pattern plays really well with what actually Flutter has introduced with Flutter 2, and this was sound null safety. So now we can utilize sound null safety and use a new object pattern to make our codes even more secure and to make sure that we are not going to be thrown on production any kind of null pointer exceptions. So you're going to see how this can be achieved. Okay,
that's good.
Cool. So let's go to the data layer and start with the actual APIs. So again, as you can see here, I have two files. The first one is just an abstract class of the movies API. This movies API is pretty straightforward. It has two functions: get popular movies, get movie details. However, as you can see here, the movies API is giving back a future list of movie DTO. So you would ask why we have movie DTO and movie. Why we have movie details DTO and movie details? What is the difference? Well, if we go to movie DTO, which is situated again in the network package in the models. If you go to the movie DTO, you will see that all the fields here, they are nullable, which means that this might have a value, or actually it might be null. This might have a value, or actually it might be null. Why it's really important to have all your fields nullable in your movie DTO, in your DTO objects? Because we are using the DTO objects to communicate with our backend. And sometimes it might happen that the backend decides, okay, I'm not going to give you back this field, or actually I'm going to give you back null for this field. And you cannot always be sure, no matter you have a contract with that backend. On the front end, we should secure ourselves from stuff like this. And what happens in this movie DTO object is we have two factory functions for creating this movie DTO. We have from map, which is it receives input parameter as a map of string and dynamic, and we are just saying this map we want the ID field, or this map we want the poster path field, and it's similar with some kind of a JSON file and JSON string, and we have again equality. So for now, this is really easy. If we go back to the movies API, absolutely the same happens with the movie details DTO. I'm going to be pretty fast on that one. Again, all the fields here are nullable because you might have them or you might not. Okay. So the implementation behind the movie API, the movies API implementation, is again rather easy to follow. The movies API implementation, it receives only a single parameter, the API provider that was defined in core. So that's really nice because then if we want to have another API for something else, for instance, users API or something, it's going to use the same API provider that we have defined in core. So the implementation behind the get popular movies and get popular movie details, we're awaiting for a result from the API provider passing the specific endpoint that we want to hit. We are waiting for this result, and then actually we are creating the result is just a map like a JSON, and we are passing that map to some kind of to a response, which actually I haven't shown. Sorry about that. It's just the specifics of how the JSON is structured. It has a result, so that's the only thing. But then we get a result of this, and we are constructing our movie DTO objects from map. So basically, we pass here the JSON map from the response. And again, with the movie details, as you can see, it's easier to follow here. We have a movie details JSON, which is map of string and dynamic, hitting this endpoint here. And what we do, we are just creating our movie details DTO from this map. And that's it, basically. And now, actually, we want to talk about the mappers. Why are the mappers so important? The mappers are important, and we have movie details mapper and movie mapper. To be honest, let's go to the movie mapper. It's easier. The mappers are important because we are mapping the objects that we receive from the network to our domain objects. Why is this important, and why we are not using the objects that we receive from the network? Because the objects that we receive from the network might change a lot often than the domain object that we have. And we don't want to, in this way, couple our business logic, our domain movie model with the network. And that's why it's really important to have mappers between your network models and your domain models. The mapper is pretty easy as well. It has only a single function map, which is receiving as an input parameter the movie DTO, and it's giving back a movie. And what happens here is we are creating a movie object. The idea of this movie object is actually depending on what happens with the movie DTO. So if the input ID is different from null, we are saying input ID, which is of type string, but I want in my movie ID, it has to be a string. I'm just saying input ID to string. Otherwise, I'm returning empty string. And for the image, I'm mapping the image URL, which if I go here, again, if the DTO image URL is different from null, I'm mapping a URL. Otherwise, I'm returning back an empty string. And that's the thing with the null object pattern. Now, in our movie object, all the fields, they are strongly typed. They cannot be null. And this is pretty important later on for our follow-up logic in the presentation and so on, because we are not going to care whether this property is null or not. And thanks to Flutter and the sound no safety, now we can do this rather easily. For the movie details mapper, is absolutely the same. And actually here we are using a extension function that we have written. For instance, for the title, we want to map the input, which is the movie details DTO title, which might be null, but we don't want it to be null. This extension function is just saying, okay, if you're not null, I'm going to assign it to title, but if you're null, I'm going to give you a default value of an empty string, which is absolutely fine. So you're not going to have to worry about null objects in your presentation layer later on, and your in-domain layer as well. And I think we are behind with time, so I don't want to show you the tests right now. The DI is again the same, and as I said, we are going to share the project later on, so you can check out the tests as well.
Yeah. So I'm not sure. Should we skip the presentation layer and maybe show how the application functions? So lastly, in our layered architecture, we're gonna talk about the presentation layer, which is finally, after we went through the domain and the data layer and everything, we arrive at the UI, which is we're gonna use presenters here and models. The good thing about actually good written architecture is that you can use any type of pattern you like. It can be block, it can be MVVM, MVC, whatever you want for here. Here we're going to use just simple presenters. And the point is that we're going to use our presenters and models to execute use cases and actually take all this data that we gathered and present it to the actual user. And yeah, we're going to achieve this by looking at our features. We have our two features as usual, the list and the details. And we have separated, as I've stated, we have three separate classes for all of these. We have the view model, the presenter, and the page, which will be the actual UI, which is going to contain all the Flutter widgets and everything you need to present.
So we are using here the presenter model pattern. We have a simple presenter and then a view model with the specific information that needs to be presented on the UI. And this is using streams. It's not have like a reference to the view. It's not an MVP. It's presentation model. But to be honest, this doesn't really matter, because having a separation like this, layered separation like this, what we are showing, is actually enabling you to have any presentation you would like. For instance, if I'm working in another team in the same project, and in my team I decided I would like to use block, which is absolutely okay. You can use the same use cases, the same domain logic, and you don't care about the data at all at this point. You can use the same things, but have this different kind of presentation pattern, which is really great actually. And are you going to show something with this, or
I don't know, maybe because the time we're really ahead and this is going to take a lot of time, maybe we're going to skip showing all of these single classes, and we're just going to maybe show the application, and then we're going to maybe answer some of these questions. Okay, so I can show the app here on the emulator.
It's not the application that was, it's the emulator that was.
Yeah, my emulator unfortunately wants to die on me, but this is how the actual application looks like. As you can see, it is very Netflix-like.
So in the application, we have two screens, as you have seen in the code. We have two features. The first one is showing, like, we have a home screen, which is all the lists here. Actually, they're showing all the popular movies from the API that we are using. So they're all the same. We have not done any separation, but it's the purpose of the sample application and this demo that we are going to show. But as you can see, indeed the UI represents and resembles a lot the Flutter one, that the real one application. And actually, having this kind of a UI, you can achieve this in probably several days, if not less, as you get more and more experienced with Flutter. And then we have the movie details screen. If you click on any movie, you can go to the movie details screen, which is showing a bit more information for the user, and the information behind the screen we get from the movie details, and get movie details endpoint. And yeah, as you can see, it looks pretty nice. But another thing that actually the Flutter team have shown, and I said it in the very beginning, is that now we have web in stable version. So Boyan,
Yeah. So this is exactly the same application. We just run it for web, and this is something really great that we now can do. And also we have a little bit of extra thing that that we did here, and it's like the responsive part. So as you can see, if I start to resize this window, the UI changes.
Actually, if you have seen this, it's kind of difficult to notice. If you're like on a smaller screen, actually the whole navigation changes, and you're on a device or a tablet, and the navigation is at the bottom. But if you're on a bigger screen like a desktop, actually the navigation, the whole UI changes. Like it is pretty smooth as well. It's difficult to notice, and now we have the navigation at the top. So with Flutter, this was so easy to achieve, and yeah, you're going to see how it is done in the project itself. But as you can see, we have the same application, both for Android, both for web. We can create a iOS simulator as well. It would look the same with a single code base, with a single architecture, and with tests covering all the important functionality. So I think that's it. Well, I don't think that we have time for more. We can talk a lot, but
yeah. Thank you very much for the time and listening to us. I'm just gonna stop sharing now, and maybe we can look at some of the questions.
There is one question. So the question is, when a user is navigating to the details of a movie, you make an API call to get the movie details. Let's imagine the user navigates back to the movies list and after watching the movie details, but then goes back to the same movie details, same movie ID. Are we making the API call once again in the case to get the movie details, or is the data persisted locally?
Yeah, this is a very good question. It's more related to the architecture of the application, and this is something really great about the architecture, that we also support this as we stated, because you can very easily write a class to persist this data, and you just have to orchestrate it through the data layer and through the repository, and you can just write a simple cache for that. And this is very, very easy to do. Currently, in our application, no, we don't do this, but in this type of architecture, it's extremely easy to do.
I hope this answers your question, Ben. So I will click answer live. Okay, we have a question from Theodora. We will say that provider is the best way to handle state in Flutter. So I wouldn't say that provider is the best way to handle state in Flutter, but I would also suggest that block isn't the best way to handle state in Flutter. And I would even say that having the state handling of what we have done is not the best way to handle state in Flutter. I think that it really depends on, first of all, on the scope of your project. If you're creating something really small, probably I would use block, because it has a really nice templating system. You can really easily create new features. But as you start growing, the boilerplate code is going to be rather like cumbersome, and we're not going to like this. And if I have to be honest, I haven't used provider that much, because the pattern that is actually we are using in this project, unfortunately, we didn't have time to show you, but I believe that you have plenty of time to do it after the presentation at home when we share the project. Actually, you're going to see that the presentation model and state handling can be pretty easily achieved with this pattern that we have. And it's not something that we have figured out. Actually, it's recommended by Uncle Bob or Robert C. Martin in his book, Clean Architecture. And this means that it's applicable not only for Flutter, it's applicable for any other language, framework, So it's agnostic. So to be honest, I really like agnostic things, which you can implement in any language or framework that you would like. So we have another question. What if we made an app as same as Netflix? Which problems do we have, like optimization, and how can we solve that?
This is a very, very broad question. I actually, to answer you honestly, I think your problems would not be with the front end. I think applications such as these, like Facebook, Netflix, and whatnot, have scalability issues, and that's why they use so very complex technologies for backend, for databases, for multiple users and whatnot. So I don't think that the front-end client would be your main problem.
And another thing here that you mentioned about like optimization and so on. So another thing really important in software engineering, I have seen this from my experience, is that you shouldn't care about optimization that much in the beginning. Worry about optimization only if you have the problem. If you see a problem, yeah, you can think about optimization. But there's a key part here that if you have a better architecture, probably in the future you're not going to be able to optimize. So that's why we want to show you how you can structure your application in a way that actually you're having your options available for later. So this is important. You should have your options available, so later on if something happens, you can optimize without an issue. Okay.
Yep.
So we have a question from Bogomil. Different endpoints can return different kind of API errors specific to the endpoint itself. Meanwhile, all endpoints can return errors that can happen for every endpoint. Okay. My question is, how do you define your errors in Dart? There are different approaches to this. A got error type that contains all error types, a base class with different implementations where you need to check what is the type of the error with each instance of etc. Or you can define a new type that is a composition of the errors that can be returned by the given endpoint. An example in Arrow's union type, where you can have union authentication error, invalid field error. What's your approach in Dart? So do you want me to answer or you can answer?
Yeah, go ahead.
Okay. Usually what we have done in the project that we have worked with, we never went with the concept of having a got error type. Having a got error type actually gives you a few problems that you don't want. First of all, where are you going to define this got error type? Probably you're going to define this got error type somewhere that all the features have like dependency to, which means that actually you have a single, you're violating single responsibility as, yeah, it has one responsibility, having errors, but then all the features and all the new upcoming features, they're going to have dependency to this one. But not only that, but this means that the features, the different features actually kind of like have a know about each other because of this got error type. So this would be a better approach for me. Indeed, what I would suggest is you should have, as you have seen in what we have shown, you should have like domain-specific errors for the certain feature, and having domain-specific errors like this, actually, in later on, you don't care about. You wouldn't have an authentication error. You would actually have something like movies, get movies popular exception or error, as you have seen. And yeah, inside you can have then inside this error you can have the reason behind that, which then can be some generic thing like which can be defined in your core logic, like actually authentication error. But I would go, even if you have duplication for the errors and for some of the code in the different features, I think that's absolutely okay. As I said, duplication is not a bad thing. So, and duplication is not a bad thing sometimes. Let's not be black and white. And I would personally create domain-specific errors for the features, and they might duplicate, but that will be okay.
Yeah, you have to map your specific errors when you need them. You can always have a generic error and just have a generic case for it. You don't need a code error. And they shouldn't know about each other.
Okay. So Ben is saying, thanks for the answer. Just to follow up on my previous one about persistence of the data, how would you cache the data? Any package you would suggest? I had a brief look at SQL, SQLite, but that does not seem to support web. So really nice question, Ben. And to be honest, at least me, right now, I'm not prepared to answer this question, as the applications that we have done up until now, they cared a lot about security, and having the security as something you should care about is sometimes implies that you don't have like local persistence on your device, or as you mentioned about web. What we have to optimize, especially the problem that you mentioned with having movie details and movie list, it's okay. It's absolutely okay to have like internal in-process memory caching, like just some kind of a map or something that you implement, like a local cache. But what we can do, just contact me or Boyan later on, and we can work together on the problem that you have, and we might go through several solutions that you find, or we can help also finding some. And yeah.
Okay, we have another question from Bogomil. You might have already mentioned it, but why did you choose a service locator pattern over inject that package or an alternative? So first of all, service locator is a bit simpler just to look at, but in general, I don't think there's I haven't come across a really good DI framework in Dart, and Get It seems like it's working pretty well currently. There's no specific reason that we have chosen service locator over dependency injection.
So for the purpose of this sample project, Get It actually plays pretty well. Indeed, you need to later on, you haven't seen that unfortunately, but you can see it in the project on GitHub, that you have to write a little bit more code, but at least you don't have boilerplate code. But also actually, I haven't used inject.dart, but I can see now that it's a compile time dependency, which is okay. It's more secure, as you're not going to have issues on runtime, but then you have issues on compile time. But as I said, the way we have done the dependency injection in the application, it really doesn't matter what kind of a dependency injection or service locator library you're using. You're not coupled to anything. So you can use inject, you can use Get It. Also, we have more experience with Get It, as we have used it in a few projects. So probably that's why we chose it.
Yep.
Okay. Okay. Do we have any other questions?
Okay, it seems we don't have.
Yep, it looks like that we are out of questions. So thank you a lot. Actually, we have something in general, like optimization. Okay. It's just an ongoing conversation.
Okay. Yeah.
So, guys, I hope you liked what we have shown, and yeah, it's a lot of material that we tried to cover in the past hour, actually, and it might looks for some of you it might look a little bit complicated, but actually it really isn't. And the cool thing here is that you can follow this kind of a pattern in like lots of lightweight front-end Flutter applications that you're hopefully going to create in the future as well. And you don't have to worry about code coverage, testing, or stuff like this. And believe me, you're going to have really well-tested code and really well-working features. Yeah, of course, if you want to contact us on any matter, just ping us. You can also find us. We have just published the Flutter. We have Flutter.bg group for Bulgaria, which is one of the first Flutter-related groups in Bulgaria. And yeah, you can find it on Facebook. Just type Flutter.bg. Yeah, thank you, Sofia. I think this is it. Or
yeah, thank you very much. We are going to share the GitHub repo through Facebook or through the Facebook group.
Yeah.
So yeah, we're gonna share it with everybody. I think yeah, I'm just gonna double down on what Evgeniy said. I think for newer frameworks where people are just trying to make small applications, just figuring things out, I think application architecture is extremely important, no matter what language or framework you're using. So this is why we just were a bit more heavy on the theoretical and the architecture side. But I think actually, if you follow along this kind of architecture, like the clean architecture that you'll see in the repo, you can actually finish the whole, as homework, you can finish the whole application, the whole Netflix application or any other application you would like to do, and it's going to be very easy to do and structured, which is, I think, really important when you're starting something new and you're just figuring out how to do things on a new framework.
And thanks to Flutter, it's going to work on iOS, on Android, on web, in your car as well. If you have Toyota,
you can save a lot of time.
Yeah. So I guess we can pass the session to Sofia.
Yep.
Okay. Cool. So we were planning to have a really big keynote, but the guys are so engaging and we're running out of time. So share with you the intro to the Flutter Engage event that happened in March. It's just going to be 7 minutes, and I'm going to share with you the link, which is 4 hours long. For those that are so enthusiastic about Flutter, can watch the whole Flutter Engage event on YouTube. So just a second, I'm going to share my tab. You're able to see my screen?
Yeah.
To Flutter Engage. We're so glad to have you join us virtually, wherever you are. It's been a tough year for many, and so we're thrilled to share some good news as we show you some of what we've been working on and announce some new things that we think you'll like. Our theme for this year's event is to highlight the flexibility and portability of Flutter as a complete UI toolkit for building beautiful apps for any platform. And today is a key milestone for Flutter with the launch of Flutter 2, a major upgrade to Flutter that builds on the momentum and foundation of previous releases and opens up a broad range of new target platforms for production use. Over the next hour, you're going to hear us talk about Flutter on Android and iOS, as well as web and desktop. You're going to hear from companies like Microsoft, Canonical, and Toyota. And you can learn more about how our work on Dart provides a unique technical envelope for your code, providing a portable, productive, and robust combination of capabilities for building apps. Flutter is the first UI platform that is designed for an ambient computing world. And this vision is unique to Flutter, a portable toolkit for building beautiful, native, fast experiences wherever you might want to paint pixels on the screen. Our goal is to shift you from having to start with the platform you're targeting and focus instead on what you want to create. Some UI toolkits impose tight constraints on what you can build. They limit your creative expression to what fits within the toolkit. But Flutter allows you to handcraft beautiful experiences where your brand and design comes to the forefront. Flutter is fast. It compiles your source to machine code. But thanks to features like stateful hot reload, you still get the productivity of interpreted environments, allowing you to make changes while your app is running and see the results immediately. And of course, Flutter is open, with thousands of contributors adding to the core framework and extending it with an ecosystem of packages. So the big news in Flutter 2 is that we broadened Flutter from a mobile framework to a portable framework, unleashing your apps to run on a wide variety of different platforms with little or no change. As of right now, there are already over 150,000 Flutter apps out there, and that number has doubled just since last summer. These apps come from big teams at big companies, as well as entrepreneurs and startups who simply want to share their idea with the world. And we thought we'd show you some of our favorites.